This is our last recording for Chapter 6. In Lesson 6.2, we're introduced to the idea of working in reverse. So, for example, if we want to find specific data values for given percentages using the standard normal distribution. So what we would like to find a particular z-value or x values, we could do either, when we're given areas under the normal distribution curve. In other words, we're working in reverse. So this requires the inverse norm command. Okay, so we want to make sure that we take note of this. This is our command that we're going to be using right here, this inverse norm command. So inverse norm, area to the left, that's real important, then the mean and standard deviation are the three parameters that we're going to be using. Now, you probably have already seen this command when we were doing normal CDF earlier. So if we go back over here to our calculator and work with second bars, that's the distributions. Choice 1 we're not going to ever use. Choice 2 is if we know the z values or we know the x values and we're trying to find the area, then we use normal CDF. Choice 3, inverse norm, is if we know the area and we're trying to find a z value. So that's the command line we want to use, and we've got three things that we've got to input into that command. That's area to the left, the mean of the distribution, and the standard deviation. So let's look at a problem back over here on our page. In this one it says, draw a sketch and state the calculator command used to solve. So given the area to the left of z is 0.38. Now, I don't know what z this is. I know here the center of a z distribution is at 0 and the standard deviation is 1. So, I can find some of those values. Let's see, make this 1, 2, 3. And working back here to the left, -1, -2, -3. What this is saying is that the area to the left of a particular z is 0.38. Now, if the z was 0, the area to the left would be 0.50, right? Because 0 splits that standard normal curve into 2 halves. So 0.38, I don't know really where it is. I'm just going to kind of draw something in here and say, okay, suppose it's somewhere along in here. And this is about 38% of the curve. So the area, that area there is 0.3801. That's the shaded part. And what I'm trying to figure out is what is the z value down here on the axis? What is that? Okay, so my command says I'm going to use inverse norm because I want to work in reverse this time. Type in the area to the left, and this is area to the left, so that's 0.3801. And the mean for this distribution, since this says z, I know the mean is 0 and the standard deviation is 1. So in my calculator over here, I'm going to type in the area, back over here, 0.3801. The mean is 0, standard deviation is 1. We'll paste that in. So everybody's screen looks the same now. And then hit enter. And what we get is negative point, I'm just going to round this off 2 places, negative 0.31. So that means this value is located right here, negative 0.31. That's the end of that shading for that particular problem. So now in the next question, let's got one again, oh my goodness. And the next question says, given the area to the right of Z is 0.65. Well, I've got to have more than half, so I'm over here in my drawing, here at 0 is half. So to the right of that is 0.65. So I'm just going to estimate something here. We'll say this is 65% of the area. And that shaded part is 0.6522. Now here's where I've got to be careful, because with the inverse norm command, I always want to work with area to the left. So that means I've got to find out this area to the left. Well, if the area to the right is 0.6522, the area to the left has to be the complement, right? Or that's 1 minus, because the total area is 1.6522, which is 0.3478. So that area right here, the unshaded, which I'm filling in with red now, that area is 0.3478. So that's what I want to use with my inverse norm command. I want to use the area to the left. So I'm doing inverse norm, area to the left, which was 0.3478, 0 and 1. And let's see what our Z value is. So second distribution, choice 3, 0.3478. Should be pretty close to the other one, right? Those numbers are pretty close there. And this ends up being negative 0.39. So this answer right here is negative 0.39. That's going to be the Z value. Okay. Now, if I have a normal distribution with a mean of 24 and a standard deviation of 5, now notice it's no longer standard normal. So the mean here is sitting at 24 and the standard deviation is 5. So I'm going to count off 5 here and get 29, 5 more, that's 34, 5 more, and so on. Each standard deviation is 5. And I'm told, and I'm given the area of the middle is 40%. Okay, now I know if I go out 1 standard deviation on both sides, that's what percent based on the empirical rule? 68%. So if this is 40%, it's got to be a little bit less than 1 standard deviation on both sides to be 40%. So this area of the curve here is at 40%. Now, with that area being 40%, remember with our inverse norm command, we need to know the area to the left. So I'm trying to find this value down here on the axis. So I need to know this area to the left. Well, the total area is 1. If I pull out the 40%, what I have left is 60%. And when I split that up into 2 parts, that means this area has got to be 30%, and this area over here is 30%. Does that make sense? Because I pulled out the 40% from 1, and then I divided that in half. So my command for this one, to find this particular, I'm going to find both boundaries, but one of them is going to be inverse norm, area to the left, which is 0.30, mean 24, and standard deviation of 5. So going back over here, second distribution, inverse norm, 0.30. The mean is 24. Standard deviation is 5. That's going to give us 21.4. I'll just round it off like that. So that means this boundary over here to the left is 21.4. Well, to find the boundary on the right, this one here, I need all the area to the left. I need all of that in my inverse norm command. So for the second part, the way I'm going to solve that is inverse norm. All the area to the left of that is 70%. And then our mean and standard deviation. And then just plug that into our calculator. So I'm going back to second bars, choice 3. This is 70%. Same mean and standard deviation. So that point's got to be 26.6. So that's the other boundary, 26.6. So this one is 21.4. This boundary is 26.6. So that's the boundaries for that region, those two numbers. Now, for this particular problem, we want to look at another normal distribution. It says to qualify for the police academy, candidates must score in the top 10% on the general abilities test. So they've got to be pretty good. They have to be out here in the top 10%. Assume the test scores are normally distributed. The test has a mean of 200. So the center's sitting here at 200. And the standard deviation is 20. Find the lowest possible score to qualify. Well, what we're looking for is this score that bounds that 10%. Well, remember now, if we use inverse norm, we've got to use area to the left. So in my command, I'm going to be using this area here to the left, this unshaded part. So if this is 10%, this area over here has got to be 90% because it's got to add up to 1. So our command is inverse norm, area to the left, which is 90%, our mean of 200, and standard deviation of 20. And just typing that into our calculator. Norm, 90%, 220. That answer ends up being 225.63. I'm just going to round 225.6. Now, most people, you talk about taking a test, you might get a score of 225, 226, 227. You don't usually get a 225.6. So what's the lowest score that he could make and still be in the top 10%? Well, that's got to be 226. Because if you go to 225, then that's too low. So a score of 226 is used for the cutoff. Anyone scoring 226 or, 226 or above qualifies for the academy. I'm hoping this is helping you to set up your commands so that you can use this in your ALEKS assignment.